A small independent motion picture company determined the profit P for producing n DVD copy of the recent release is P of n equal negative 0.02 n squared plus 3.40 n minus 16, where P is the profit in thousands of dollars and n is in thousands of units. How many DVDs should the company produce to maximize the profit? So here we have a quadratic equation, quadratic function, where a is less than 0. So the max is at vertex. Okay. So how many DVDs should the company produce to maximize the profit? This will calculate the n value in which that is max. So part A. So n equal to negative b over 2a. That is negative 3.40 over 2 times negative 0.02. And that is equal to and this is 85,000 DVD. Okay, so in order to make maximum profits, the company need to produce 85,000 DVD. And what be the maximum profit? The maximum profit is the value P of 85,000, and that is negative 0.02 times 85 squared. Then we put this into the calculator. So the company make the maximum profit of $128.5 thousand dollars. And this is in the unit of thousand of dollar. Okay. A rectangular lawn is measuring 4 meters by 8 meters, is surrounded by a flower bed of uniform width. The combined area of the lawn and the flower bed is 165 meters square. What is the width of the flower bed? So let's try this. Let's say you have a lawn, and this is 8 by 4. And then it's framed by a flower bed of the uniform width. And we don't know what that width is, so we let that be x. The combined area of the lawn and the flower bed is 165 meters square. Okay, so let's take a look at what is the area of the lawn and the flower bed. To calculate this area, we need to figure out what is the width of the lawn and the flower bed combined. So this is a plus 2x, and this direction, it is 4 plus 2x. So the area of the lawn and the flower bed together is 4 plus 2x times 8 plus 2x. Expanding this, we get and combine like term. We want the combined area of the lawn and the flower bed be 165. This meant this equation that we just got is equal to 165. And we solve for x in this equation. I'll go ahead and complete the square here. So because we're talking about the width of a flower bed, it cannot be negative. So then the uniform width of the flower bed is 3.5. Now, the question asks us what is the width of the flower bed, and we just found it. So then, to answer this, in a complete sentence, the width of the flower bed is 3.5 meters. Okay. Let's take a look at the next problem. A ticket to a school dance costs $4, and the project attendant is 300 people. For every 10-cent increase in ticket price, the dance committee projects that the attendance will decrease by 5. Find a function that models the revenue of the ticket price. Okay. So first, let's start by letting x be the number of 10-cent increase. Let x be the multiple of 10-cent increase in ticket price. So the revenue here, R of X, is equal to the number of attendants multiplied with the cost of the ticket. Okay, so the number of attendants will decrease by 5 for each multiple of 10-cent increase. So that will be 300 minus 5x, and the cost of the ticket is increased, so that be 4 plus 0.10, that 10 cent x. Yes, so that is your equation. And let's multiply this out and combine like term. We get so find the price that maximize the revenue for ticket sale. So since this equation is have a negative coefficient for x squared, it is the graph of this quadratic function open downward. The vertex is the maximum. So the maximum price for the ticket sale is at the vertex. So x equal to negative b over 2a. That is 17 over in this equation right here, it need to say 10 plus 10x. Okay, so negative b now become negative 10 over 2 times negative 0.05, and this equal 10. So here we said 10, but x is the multiple of 10-cent increase in ticket price, right? So this meant the ticket price will be increased. So this implies we increase $1 in ticket price. So now the ticket price is $4 plus $1 increase it to make $5. So for $5, then the ticket price, for $5 of a ticket price, we will have the maximum of attendance. Okay, so what is the ticket price that is so high that no revenue is generated? If the ticket high is so high that no revenue generated, no revenue would mean this equation, negative 0.05 x squared plus 10x plus 120 plus 1,200 equal to 0, because there's no revenue. We solve for x in this equation to get x equal to negative 84.4, or x equal to 284.4. Now, since x is the number of the increase in 10 cents, x cannot be negative in this case. So if we increase the price by $28.44, then there won't be any attendance. This meant we make no revenues.